And going back to a comment that Dave made about AI, once you get down to the nitty-gritty details, is logistic regression. So I want to ask Don to contrast maybe statistics and data science. So Don, could you give us some color about what you think the average data scientist is doing well today and what is doing poorly?
I'm not sure. Well, first of all, I want to make a comment about the terminology data science. There's this old expression, it's from Tukey from years ago when I was at Princeton, that any field that needs science in its name is not science. You don't say chemistry science or physics science. Computer science isn't science. It's really engineering. And I think that's pretty consistent with everything David said, really. It's an engineering revolution where you take machines and you make them faster and faster, and you have to cool them to make sure they don't fry themselves. But it's not science. What is science? In my world, science means understanding nature, and physics is about understanding physics, and chemistry is about understanding chemistry. What is computer science about? What's engineering? And that's okay. But I think that the name is deceptive. Also, I also found part of what David said is kind of depressing. Maybe that's why I don't like to agree with it. Basically, I think he sort of implied that ideas are dead in the field, and so therefore it doesn't make a good academic field in that sense, where ideas are paramount. So why do we need ideas? Well, to me, ideas refer to understanding, and if you understand something, you can generalize beyond what you've seen. And I think that's something that's sort of missing from the usual machine learning attitude. You're always doing tests on these artificial examples, or sometimes they're real examples, but they're limited. And with respect to that, I think one of the big contributions of the field of statistics, starting with Fisher, and then a bunch of guys who I actually met, Jerzy Neyman, George Box, Bill Cochran, John Tukey, and David Coxtel. The purpose of doing experiments is to learn and to get understanding. And I think that the understanding that is typically generated by machine learning or data science doesn't generate that. And understanding really means you understand something, or you have a hypothesis about why something's true, and you can address problems that are different from the collection of problems that have been presented. And in fact, often you get to do that by answering a different question than the one that's posed. And I don't think machines do that very well. They may be able to train machines with the collection of images or something to become better and better at solving the problem that you presented to them. But humans have a different ability. They have an ability to be creative, and they can think about the problem that you've posed. They often come up with a related but different problem that hasn't been posed. But that problem that they came up with is one that that has answers. So instead of addressing the problem being asked, humans have the ability to find a problem that's close in some sense, that wasn't posed, but is solvable. And I wrote something that was published in an obscure place when I was in Beijing last year, making this point that humans' brains are not wired like a bunch of computers. they change the problem into one that can be solved. And that's where I think many of the great ideas came from. So I'm not sure that I buy into David's future, or that it's or the game that will be played. I certainly hope not. It sounds sort of boring.
I guess David presented the dichotomy to be thought-provoking. Of course, there's a lot of details and ways for us to be in the middle, and I'm hoping Michael Kohler will speak to some of that toward the end. But thank you, Don. Thank you for being here.